In the following demo, we'll take a look at Krakatoa for 3ds Max and how you can use it to load, convert, and render point cloud data from LiDAR scans. First, we'll need to create a PLT loader. I'll hold down the Shift key, and when I click, it will ask me for the file. So I'll navigate to my NAS drive and find under the LiDAR folder my last files. There is data that I have downloaded from the internet of the serpent mount model, and if I select this file, it gets added to the PLT loader, but you'll notice that if I zoom extends, nothing really shows up. And the reason is that if we hit the update info on the particle counts, we'll see that the file name was modified. Since the PLT loader is expecting normally an animation sequence, it's replacing the end of the file with the current frame number, and that file doesn't actually exist. We would like to use the file as is, so we say load single frame only, and at this point it shows that this last file contains 3.2 million points on disk, and right now in the viewport it will be showing 32,000 because we are showing 1% of all points. If I would hit Z to zoom extends, we'll see that this is where the icon is at the origin, and this is where the data is, and it's very, very far away. So one way to get quickly to the points is to disable the icon display and then hit Z, and these are the first 1% of the points. If I switch now to 100%, it's going to load all 3.2 million points from file and will display them in the viewport. Let's switch to a single view, and we can take a look what's inside the data channels. We see that the last file contains a position and an intensity channel. The intensity channel is not a standard channel in Krakatoa, so Krakatoa doesn't know what to do with it, but what we could do is remap it to a grayscale color. In order to do this, I'll go to the Krakatoa menu, select the Krakatoa magma modifier, and then I'll open the magma editor. I'll press Shift Control and C for color output. Then I'll press IC, and pretty much any of the existing channels will do because we'll have to type the intensity by hand. So we say intensity, and it tells us, okay, intensity was actually added to the list previously, but it's a user-defined channel, and it's not a standard Krakatoa channel. So since it is a floating point value, but we need color here, we'll have to convert it to a vector. So I'll press C and V, that means convert to vector, and then I control select both nodes and press spacebar twice in order to quickly connect the two selected nodes. If I would update this modifier now, we'll see that everything is pretty much black, and the reason it's black is because the actual intensity values are very low. We can take a look at the values using the particle data view utility, and it will read and show us that the actual values are 0.0034 and so on. And down here we can see that this is the minimum value and this is the maximum value, and that is the average. So we would have to multiply it to approximately 100 in order to get something that is recognizable as color. So I'll just type in here multiply times 100, and then I'll update manually, and we'll get grayscale colors that represent the intensity of the LiDAR scan. Now if we want to zoom closer, we'll see that the serpent mount is actually in this area here, and we can switch the display from large points to small points in order to make it a little bit finer. Of course, this scan is kind of coarse and not very precise, so we cannot really zoom too close, and if we start rendering there will be a lot of gaps between the points. So this is probably not the best example to render. In order to demonstrate the rendering, I'm going to switch to a different model. I'll delete this loader, and I'll create another PLT loader holding the Shift key and clicking. I'll go once again to my Z drive, and then I'll pick this example of a car that was sent to us by a customer. This is not in a LAS format, it's actually in a worse condition. It's an CSV file, and the CSV file contains columns in a text file with values that are hopefully defined by the first line of the file. And we have exactly the same problem here. It says, well, we don't really know anything about the counts because we're not loading the points from single file. We're trying to replace the frame number for an animation sequence. Since this is a text file, it takes a lot longer to load, and it can only load in every end mode, even though we have specified first n. Since we don't know the total count of points in a text file, it has to just read and skip over and pretty much read every 100 in this case of the records. So if we take a look at the data, it appeared up there, and we can once again disable the icon and zoom closer, and we see that a color channel was loaded. And we can once again take a look, and we see that there is a position, a color, and an intensity channel in this case. So the color is a standard color in Krakatoa, and it didn't require any remapping. And the intensity could be remapped just like we did previously. Now, there is a case where all this is not defined in the file already. A LAS file, for example, would have the information about the mapping of the channels, but an XYZ file, for example, wouldn't have this. I'm going to remove this file and try to load a version from the same folder, which using all files can be picked. Pretty much any file can be picked, and then Krakatoa will try to apply all its knowledge about the file formats it supports to figure out if it can load this file. And an XYZ could be TXT or any other one. It's not really listed under the file types, but it can be picked. And the result will be very similar to what we just did with the loading of the CSV. The main difference is that it won't load beyond the position any of the other channels as color and intensity. It will load them as individual columns called data 1, data 2, data 3, data 4, and so on. And we will have to perform the mapping ourselves. And here you see the points were loaded, but the points don't really provide any of the mapping that we wanted. So what we can do is we can add again a magma modifier, either from here or through the Krakatoa menu. And if we take a look once again in the channels, we see we have data 1, data 2, data 3, those are the RGB, and this is the intensity. So we can remap them ourselves. We'll go to the magma, we will create one output for color and another output which will rename intensity. Or we can, of course, call it density or something else, but in this case, the data really represent intensity of the laser coming back after it bounces off the object. So we can now create an input channel, again, any of the channels, and give it a name data 1. And then we can copy this channel and paste it again and again. And we'll switch the name to data 2, and then the next copy will be data 3, and then we'll make another copy, and that will be data 4. So we can now combine these three, and we can say we're going to create a convert to vector operator. So we press C and V. All three get automatically connected to the RG and B, and then we go out as color, and then we take the data 4 and we output as intensity. At this point, if we would hit update again and wait for the update of the points, the point loader is going to reprocess and reread from the file because it doesn't know that we're just modifying something on the stack. Once those channels are read and converted, we're going to have a color that we can save and an intensity that we can also save to a new PRT file. Another thing that we can do is we can move this bounding box down to the origin, because now we are far, far away from the origin. And if we open the MaxScript listener, we can check the center of this bounding box. The middle is at 526 units above the origin. So we can say the center is equal to 0, 0, 0, and this will move the car exactly centered at the origin. But if you would like the wheels to be at the ground plane, we can use the maximum of the bounding box as the Z component of the center position. So with this object selected, we say $max Z, and at this point you see that the car is actually sitting on the ground plane. Another thing to keep in mind is that currently the system units of 3ds Max are set to inches. This is the default how it ships, but the actual content of the file is in meters. So this car is expressed in meters but currently appears in inches, and it will be much, much smaller than desired. So when saving a PRT file to disk, we would like to include metadata that defines that these units are actually meters. So I switch the system units of 3ds Max to meters. Now I can go and assign Krakatoa as the current renderer. I say no to switch to Krakatoa using default settings without remembering any of my previous sessions. So this is a fresh version of the Krakatoa user interface. We can now switch to save particles to file sequence, and we'll keep only the position, density, and we'll have to add an intensity channel. This intensity channel was defined manually by me previously, so you can type in yourself intensity, define float 16 and arity of 1, so one component, it's just a float, and then it will appear with a star, which means that is a custom channel. I can add this channel to the list. Now position, color, and intensity will be saved, and all I need to do is also define the output where it should save. I had already saved previously a file like this, so I can pick it and overwrite it, but I won't waste the time to actually resave it because I already have it. So normally you would just hit the button to save the particle, so it will ask you, do you want to save the position, color, and intensity to this file, and it will be a single frame, and normally you'll click yes or say no because I already have it. So at this point I can delete my existing loader, and then if I go to customize user the units and want to keep on working in inches, I can switch back to inches. But when I create my Krakatoa PRT loader and pick the file that was saved previously with meters information in it, you'll see that the file is rescaled, and this is 1% of all the points, so we can switch there to 100%. This is going to load all the 7.1 million points in the viewport, and the length in inches correspond to the length in meters converted correctly, because the actual file contains information about the units in meters. It is in meters right now. It knows the up vector, so if you're loading this in Maya, it will know to flip it correctly, and it has position, color, and intensity. What is left now is to render this. And currently we have a color channel, but we don't really want to use dynamic lighting like normally in Krakatoa. We want to render the points the way they were scanned. So with the Krakatoa renderer already assigned, we'll have to switch it back to render mode. So we go back here and say render scene particles, and we would like to render an emission channel, which is equivalent to self-illumination in 3ds Max, where the color of the points is used for as emission. I could do that when saving the PRT file. I could have copied the data already in emission, but I haven't done that. So I can either add a magma to the object and copy color into emission, or I can do it at render time. There is a global override that I can assign. I go to global render values, say create new global override set, and here we have color to color. I'll say color will become emission, so it's reading the color of the points and sending it out to the emission channel. That's all we need to do. Then we'll collapse this. It's already set up, and we'll have to enable use emission. We'll take a look in the render settings. We have 640 by 480 resolution, and we can say I want to render only this frame, no matter what the animation settings are. I want to iterate only one frame at a time. And the default settings currently for final pass density 0.5. That might be a little bit high, but we'll render first with the default settings and take a look what comes out. So it loads all the points and then it draws them. And here it is, the car. The points were sorted and drawn correctly back to front. And we get relatively solid alpha. So we could go down and try, for example, 0.01 approximately for the final pass density, and we'll see that some of the particles will now accumulate into a solid white, and wherever we have very few points, they will be much less intense. So this kind of produces a better anti-aliasing. We'll still see some aliasing there because that's a pretty solid overlapping of multiple points on top of each other. If we continue going down with the settings, for example, to 0.005, then the alpha might become too transparent and we'll start seeing through the solid portion. Let's switch the resolution to a slightly bigger output. For example, let's say we'll keep this and do double the resolution. Here it is. So this is actually pretty nice, but you can see through the 7, you can see the 8 on the back. So it's actually too transparent. I'm going to switch it back to 1 and -2, which is 0.001. And what we could do at this point is render, for example, an animation around this car, and you notice that the time to render this is about 4 seconds. And this is because the PRT file will have to be read each time we hit the button, the render button. It's going to first load the particles, which takes a little bit, and then it has to sort them and draw them. If we enable the particle cache, which is a feature of Krakatoa, and render the frame again, you'll notice that this time it just draws the already loaded particles from the previous iteration, and the actual render time is about 1.7 seconds. So we could render an animation with probably this resolution, or 800 by 600, for example. Well, let's keep it like this. And we'll create quickly a camera that is looking at this car. And then we'll go and, for example, we could speed up things a little bit by drawing only 1% of the points. We'll switch this to every nth particle display. And we'll change this to 1%. So it gives us a relatively good idea where the points are, but we don't really need all 100% of the points. It's only 71,000. Now with this camera enabled, I'm going to go to the last frame. I'll enable auto. We have to remember to enable load single frame only, otherwise nothing will really load there. And let's rotate that camera a little bit so it looks at a different angle at the car. And then we have this move. Let's take a look. We could probably go to frame 50 and center a little bit. And this is our animation. Now at this point, if I go to the Krakatoa render settings again, and disable the iterative rendering, so we can render the whole animation. We have the pcache enabled, so it will load the particles only on the first frame, and then for 100 frames it's always going to re-render the same points without doing anything, so it will last only about a second and a half. We have to specify a render output or create a new version 2, and we'll call this animation true, and we'll give it extension JPEG, for example. Now I can hit the render button, and this will start rendering in less than 2 seconds per frame. We forgot to switch to the active segment, so this rendered only the first frame. I'll go and say active segment from 0 to 100, and then hit render again. And this time we'll start getting an animation that is again taken about 2 seconds per frame. That's mostly because of the saving to JPEG, which takes a little bit longer than just pure rendering. And after we render all 100 frames, we are going to take a look at the result. Okay, we are pretty much done with the rendering. There is the last frame being saved, and at this point we can take a look at the result using the RAM player of 3ds Max. So we go to render, compare media and RAM player, and go and pick the output that we created. This is the single frame that we rendered without animation, and these are the 100 frames that we want. So we say we want to load the sequence. This will create an IFL file containing all the 101 frames. We say OK, and then we load all the frames, and there is the animation being loaded. Once it caches it in the memory, we can then play back. Currently I have 24 FPS, and here is the camera move that we generated. As you can see, we can use Krakatoa to read various LiDAR file formats or even text files created from really any source. We can remap the channel, so we can use automatic mapping depending on whether it's available in the file or not. And we can resave to our own PRT formats to have much faster access to the data. And then we can render it with its original colors without applying any dynamic lighting, which normally Krakatoa would do with other particle sources, in order to visualize LiDAR data set as a moving image.